This video is about displaying data in a box and whisker plot, and it's lesson 54 in your book. Now this is going to be a little different than what we normally do because I'm just going to give you the background information in this video, and we're going to work out actually plotting the box and whisker plots in class. So we're going to talk about all the different parts of the box and whisker plot and what they are. A box and whisker plot displays data that are divided into 4 groups. So it basically is a good visual way to see where the center and the ends of the data are. Now, there's a line inside the box, and you can see that on this example right here. The line inside the box is the median, and we know how to find the median because we line all the numbers up in numerical order and then eliminate the first and last numbers until we just have the center number. If you have 2 numbers in the center, you have to find the average of those 2, and that gives us the median. Now on the ends here we have the minimum and the maximum. The minimum being the smallest number and the maximum being the largest number in the data set. And then in between here we have the first quartile, which is the median of the first half of the data. And on the right side of the box we have the third quartile, which is the median of the upper half of the data, or the right half of the data. So when we create a box and whisker plot, there's a number line, and we find each of these values, the minimum, the first quartile, the median, the third quartile, and the maximum, and we plot them on that line. And again, we're going to talk about that further in class. But in this particular example, there are 15 hockey games, and this number set right here describes how many goals were scored. So if we were to display this in a box and whisker plot, we could find the median to make our center line by crossing out each one on the ends until we got to the middle, and this one shows us that the median is 5. We would plot the minimum as a point above the number line, so the minimum here is 1, and the maximum, same thing, so the maximum here is 9. And then we would find the first and third quartiles and plot those as the left and right side of the boxes. Now the quartiles tell us where the first quarter of the data is and the third quarter of the data is. So it basically creates our other fourths, and the median's the half. The first quartile is the median of the lower half of the data, and the third quartile is the median of the upper half of the data. So the median divides our data in half. We use the first half and find the median of that to get the first quartile. We take the second half and find the median of that to get the third quartile. So on this page that we just did here, we know that the median is 5, so we would not use 5. Our lower half of the data, we would find the median of that to get our first quartile. So when we cross off the first and last, first and last, first and last, we find that the first quartile is 3, and that's why this line is plotted on 3 here. To find the third quartile, we would use the upper half of the data, or the half that's bigger than the median, and cross out first, last, first, last, first, last, until we got to the median, which in this case is 8, and that's why we've got 8 plotted as our third quartile here. Once we find those quartiles, we can use them to plot our box and whisker plot. However, we can also use them to determine outliers. So we have this thing called the interquartile range. Now we know that the range of a set of data is the biggest number minus the smallest number. The interquartile range is the biggest quartile minus the smallest quartile. So we take the third quartile and subtract the first quartile. Now in this previous example, our third quartile is 8, our first quartile is 3. So to find our interquartile range, or our IQR, we would take our third quartile minus our first quartile and subtract them and get 5. And 5 is our IQR, or our interquartile range. The interquartile range is helpful when you're trying to find outliers, or to decide if some number is an outlier. And in order to do that, we use these formulas right here. Now, if a number is less than the first quartile minus 1.5 times the IQR, it's an outlier. Or if a number is greater than the third quartile plus 1.5 times the IQR, then it would be an outlier. So for example, in that last set of data, our third quartile was 8, our first quartile was 1, and then our IQR was 5. So if we wanted to figure out which numbers were outliers, we would use these two formulas. The first one would be x is less than the first quartile, sorry about that, x is less than the first quartile, which is 3, minus 1.5 times the IQR, which is 5. So it would be less than 3 minus, and 1.5 times 5 is 7.5. 3 minus 7.5 is negative 4.5. So if we had a number in that data set that was less than negative 4.5, it would be considered an outlier. On the larger side, we would use x is greater than the third quartile, which is 8, plus 1.5 times the IQR, which is 5. .5 times 5 is 7.5. So if x was greater than 15.5, that would also be an outlier. So in order to find our outliers, we have to know our quartiles and we have to know our interquartile range, and then we simply use these formulas. And then here's just one more example about using the quartiles and the IQRs to find the outliers. Now, here our box and whisker plot shows scores on a history test, and we want to use the IQR to identify any outliers. Now, we can see from this box and whisker plot that our first quartile is 70, so that's what we have here, and that our third quartile is at 90, so that's what we have here. Now, to find the IQR, we would subtract those two. 90 minus 70 is 20. And then we know that in both of those outlier formulas, we're going to have 1.5 times 20, which is 30. So our 1.5 times IQR is going to be 30. In order to find our outliers, we would use those formulas. So we've got x is less than the first quartile, 70, minus 1.5 times the IQR, which is 30, which would give us x is less than 40. So if we had any data values in the set that were less than 40, they would be considered outliers. On the upper half, we'd have x is greater than the third quartile, 90, plus the 1.5 IQR, so 30 again. And when we simplify that, it gives us 120. So any numbers that are greater than 120 would also be considered outliers in this data set. Now, we'll go more into detail in class about how to actually plot the box and whisker plots, but that's all we're going to do for now.